Good morning. Good morning. All right. Excellent. One correction to Sam. I always like to correct Sam. It isn't patent leadership for 24 years, Sam. It's patent leadership for 25 years. So what I'd like to do this morning to introduce our conference is just try to put in perspective what's going on in the world of information technology and how, just a few examples of how it's affecting multiple industries and in particularly governments. Now, to sort of calibrate you, I'm looking around and sort of trying to guess. I know I shouldn't try to guess ages. That's a very dangerous thing to do. But that's right. But I have 38 years, nearly 4 decades in the information technology industry, working with IBM, for IBM, and on leading edge technology, and I've built systems and software and all sorts of things. And in my 4 decades in this industry, I can tell you seriously that I have never seen a moment like this moment in time. And I say that because, as you'll see in a few minutes, we've had lots of technology waves come through and have impact on us, and we're all sort of seeing and feeling that. But never before, certainly in my history and career or before me, have I seen a point in time where so many technology changes are converging at one time. And it's not 1 + 1 + 1 = 3. They are compounding each other and accelerating each other. And that's what I want to try to convey to you this morning. Now, why is it that we feel things are moving so quickly? And why do we sort of feel a little bit disoriented? I was talking to a lot of my friends from around the agencies on the way in this morning, and everybody was saying, boy, John, there's a lot going on. We're just trying to keep up with this stuff. The reason that is that things are not progressing at a nice sort of linear path of speed in time. Things are actually moving and increasing at exponential rates. And if you sort of remember nothing else I say or show you this morning, please try to remember this picture. It's seldom that exponential increases in things come along in nature or in technology, but there are 3 of them that you sort of need to understand. The first we all know is the infamous Moore's Law, which says that the number of transistors or the performance of a chip or a computer system doubles every 12 to 18 months. That is a powerful, powerful statement. When I joined IBM in 1980, we were putting 1,000 transistors on a chip. We now put 10 billion transistors on a chip powering our systems. It's incredible. It's the reason why the compute power in the smartphone in your pocket or what you're taking your photos with outperforms everything in computing just a few years ago. Exponential increases. That created leadership for companies that didn't ride on those, or agencies that didn't ride on that are gone. They're toast, because you can't catch up on an exponential curve. The second one, you probably know it as the network effect, but you may not know it by its name, Metcalfe's law. That one says that the power of any network increases basically as the square of the number of nodes. The square of the number of nodes. That is the internet effect. But when you look at companies and entities then that have rode that exponential curve, think of the social networking companies. They are fundamentally only as good as the number of people and devices they can add to that network to ride up that exponential curve. And once again, companies or countries or governments or agencies that create those networks and expand those networks in exponential ways benefit from that. Those that don't, again, will be victims of that curve. There's a third exponential now, which, again, we can choose to either take advantage of it or be victims of it. And I'll, for the moment, sort of call it Watson's law, being, I guess, the father or grandfather or something of Watson. And this says, basically, that the underlying exponential is the growth in data. Data in the world is doubling every 12 to 18 months, and it's actually accelerating faster than that. Now, data in of itself, in size and diversity, is of little interest or little value, just as an expanding network in and of itself is of little value. But if we can extract knowledge from all of that data and keep up with that exponential growth in data, now for the first time in human history, we can scale our knowledge with the growth of data, both in time and space. So we as humans now can start to learn faster than our natural processes and make better decisions faster than our 20-watt carbon-based brains can do. And that is a really powerful thing. So from that you have to conclude data, as we sort of say, is the natural resource, but we really have to refine that data and extract information. And the only way we as humans can keep up with that curve is to use artificial intelligence or cognitive computing. And we decided a long time ago in our systems that if we tried to just use programming to extract information from all of that data, we would run out of human beings. If every human being on the planet was a programmer, we wouldn't have enough programmers. So we had to build systems that learn on their own, aka artificial intelligence. So this is a really big deal. The other thing I will tell you is that each one of these curves, as you know, lasts 50, 60, 70 years. They don't go away. And we are at the very beginning of that third exponential curve. It all started, in a sense, back on February of 2011 when we showed that first artificial intelligence system, Watson. So what are the components then of extracting that knowledge at exponential rates from the data? The first one is cloud platforms. If you're going to absorb and ingest and deal with that much data at exponential rates, you can no longer just buy a box and put it in a data center and keep up with the explosion of data. You certainly can't rely on a few boxes or a few pieces of code to do the artificial intelligence, machine learning algorithms, the deep learning required to extract the information. You need essentially almost elastic infinite compute power. And the only way to do that at reasonable scale and reasonable cost is through cloud technology. So lots of people today will refer to cloud as just a cheaper way to do things, and I don't have to invest in the capital, I'll just do it in the cloud. That's true, but that's not the real reason to go to the cloud. The real reason to go to the cloud is to get the storage and compute power to deal with that third exponential. And when you do that, you extract extreme value from your information at reasonable cost. So all of these things around scalability, flexibility, security, and resiliency are critical. You will get more resiliency and backup and recovery capability in a cloud such as IBM's cloud or any of our competitors, although I would argue we do it better. But if you're going to now take your computer systems, your AI systems, and put them right in the middle of your critical decision making, the last thing you want is that system to go down. And whether you're a government agency protecting our borders or whatever, or a healthcare organization and a doctor doing a diagnosis, at the moment, you do not want those systems to go down if all of your data and intelligence is in there. So this is a big deal around cloud. And I'll come back to security later on. So then why AI and why now? Why did all of a sudden AI pop out of the woodwork and everybody's yapping about it? As Francis said, lots of people are talking about it and not a lot of people are doing it. We are doing it, and we're doing it with many of you. Well, the first thing on the why now is that the chart I showed you before on data. Exponentially increasing. And it's not just the volume of the data, it's the diversity, the multimodal nature of this data now. I'm just looking here and I'm seeing, okay, some people are typing stuff in, putting data in, some people are taking pictures, digital images, some people are on the phone with digital voice, some people are using voice recognition. This is all data, but it's all different kinds of data. It's no longer just easy ones and zeros for computers. Secondly, we have the cloud, as I said, for the compute power. And then thirdly, the sort of perfect storm here is we finally made enough progress in artificial algorithms, coupled with that digitized data, coupled with the high-power compute platform in the cloud, to be able to do very, very sophisticated machine learning, deep learning for artificial intelligence. And when you put all those things together at a moment in time, we were able, starting in 2011, to launch on this time the true AI curve. And so it is real. And it's so real that everyone is talking about it. But I wanted to spend 1 minute to get back again to Francis' point and just calibrate you on what is AI and where is it going and sort of where are we today? Because there's a lot of hype out there and lots of people are saying a lot of things. So let me describe it this way. On the one end is something I'll call narrow AI. And this is getting a computer system to recognize an image, as an example. In this case, no matter how you disguise a cat or a dog or your pet, these computer systems will recognize that that's what it is. Or if there's a defect in the manufacturing inspection, these systems will easily recognize that. And we can train the machine to be really good at recognizing that. And so in your phones or in your cloud, your family pictures, you say, well, who's organizing my pictures into these albums? It's those kinds of sort of narrow machine learning capabilities. On the other end of the spectrum is something that people talk about, aspire to, and also worry about, which is general AI. And this is call it the magical black box that can do and answer anything and knows everything. And people worry about it being, quote unquote, some sort of singularity or it's going to pass us. We will get to the point where these systems will be very powerful, but I don't believe they're ever going to do the kinds of things that this, not mine, your 20-watt brains can do, for lots of reasons that we can talk about separately. But that is decades away, trust me. And we have researchers and other companies have researchers working heavily on the extremes of that. But in between now and decades from now is a whole set of opportunities with the data we have, the AI we're developing, and the clouds we're developing and have to do a lot of great work to ride that exponential curve. And we are seeing companies and governments around the world, every enterprise now grabbing onto this and trying to ride that exponential curve and differentiate their companies, their enterprises, or government service to their citizens by leveraging AI over the next several decades with these kinds of technologies. So as Sam mentioned, one of the advantages of being with IBM is that you work in every country in the world and you work in every industry, every enterprise. So we see it all. And as I said, we are seeing every industry not just now leveraging cloud and AI in their data. We're seeing massive transformation of entire industries with this technology. Because think about it, when you couple these learning machines with all of that information, with the human expertise, you are going to radically change industries. And I'll give you a couple of examples. But just on this page, I've just chosen a few. Financial services, I'll say more about, all the way from call center, digital bot operators, through fraud detection with very sophisticated artificial intelligence. In retail, optimization not just of the consumer experience, but the whole supply chain through to the consumer. Healthcare, I'll give you one example in a minute, but healthcare is going to become a digital enterprise, end to end, all the way from drug discovery to care, from your physician and your health care. Oil and gas, all the way from exploration and analysis of seismic data to end consumer buying of the petroleum products. Genomic medicine, supply chains, etc., all being radically transformed. And again, I'll jerk you back for a minute to those three exponential curves. At the beginning of Moore's Law, we could not foresee, other than in science fiction, those smartphones that you're holding in your hands. But we did it. At the beginning of that Metcalfe's Law, with the first DARPA internet, we could not foresee what the internet was going to do to every industry in the world. And I would argue, as much as we try to look forward now as to what AI and cloud technologies will do, we can barely see the next 5 years or so of what will happen. But think about what will happen over the horizon in 10 years or so in these industries. Completely changed. So let me just give you two examples quickly. One is financial services. And as I said, on the one end, we now are not dabbling, to Francis's point, with AI. We are at scale with tens and hundreds of thousands of calls being answered by major banks and financial institutions, not just in the US, but I used mostly non-US, around the world. And when we look at this data and the results, the precision of these artificial intelligence systems now exceeds that of human beings. Its ability to understand natural language and answer a question from someone calling in for help exceeds most human beings. And as a result of that, what we're seeing is that the customer satisfaction in these banks has gone through the roof because, number one, obviously, the machine's going to answer a lot faster than people queuing up. I personally like that. But the precision of the answer and the fact that the machine will answer 9 times out of 10 correct versus being bumped to level 2, level 3, and we've all been through the frustration of that. So that's on the one end. But as I said before, these systems now can basically listen to a conversation and know whether a transaction is fraudulent or not. And that's because when someone is committing a fraudulent act or transaction, they speak in different ways, they use different words, they use different cadence in their voice, and we can detect whether that action is fraudulent and turn it down in the banking system. So all the way from simple calls to very sophisticated transactions. I mentioned healthcare. This is one where obviously it's an enormous industry. It personally touches every one of us and our families, but it's one of the biggest opportunities to transform. We know that the explosion in cost in healthcare is bankrupting some countries, enormous portion of the GDP, and we know the results are unacceptable from the healthcare system, if we want to call it that. So can we use this technology? The answer is yes. So we took our Watson system. We decided that we would go after one of the largest, most difficult diseases facing us, cancer. And we took our artificial intelligence system and went to Memorial Sloan Kettering, one of the top cancer institutes in the world. By the way, if you're going to train an AI system, make sure you train it with the best, because the system is only as smart as the data and the people who teach it. So remember, always go to the best people. So we went to Sloan Kettering. We have taught Watson 16 cancers. The first cancer, it took it about 3 months to learn. It now takes about 3 weeks to learn a new cancer. And it will basically ingest a patient's entire medical record. It has ingested all of the Memorial Sloan data, historic patients and results, has read all the medical literature, is updated every 24 hours with every new publication, and basically will do what you see on this screen. I apologize if you can't read it, but presents to the doctor for that patient instantaneously with the patient what it would say is an optimum protocol to follow for this particular cancer patient. The proper mix of what is the right chemotherapy, what is the right regimen of radiation, and potentially surgery. And again, seconds to do this. Now you say, okay, well the docs at Sloan Kettering are pretty good. They may not need a tool such as this. But the interesting thing then is because this is available on the IBM cloud as a service, any place in the world, any oncologist can access that system and get a set of data and options for their patient. This is exploding in the Pacific Rim of Asia. And the reason is that it takes so long for new therapies to go from Memorial Sloan Kettering in New York City to Mumbai or Shanghai or you name it in the world, that it's no longer years. Literally in seconds, the best knowledge from Memorial Sloan Kettering can be in Australia, South Africa, China. So we are getting an explosion of growth in this technology. And why is it important? Well, it's important because the scale of the problem in these countries with cancer is off the charts. If you look at India, 1.3 billion people or so. When I spoke to the head of the hospital at Manipal, he said to me the following. He said, John, there's 1.3 billion people in my country. Only 300 million of them can afford to see an oncologist. And then guess what? I can't even serve them because I only have 1,000 oncologists in the whole country of India. So I need something to scale knowledge as fast as I can. He said, even with all the money in the world, I can't build medical schools fast enough to propagate the knowledge and get them out to the people. So these kinds of technologies are not only enhancing the very best physicians, oncologists in the world, they're spreading that knowledge globally in seconds, This will transform healthcare. Now I want to leave you then with 3 thoughts on things to think about throughout the day. Number 1 is security. And I'll put it this way. If you think we have security and cybersecurity problems now, you ain't seen nothing yet. You ain't seen nothing yet. Why is that? Why is that? You say, well, gee, John, we're getting out of programming. We're going to this wonderful world of AI. Security issues must go away. Not true. Let me give you a simple history and example here. The history of cybersecurity, of course, when we started back in the 60s, we built these glass houses. They were highly secure rooms. They would have been vaults. We put glass on them because it was cool to have a computer in the 60s that you could see, but you literally couldn't go in and touch it. Then we moved to the world of today where people are hacking, putting programs in, malware, you name it, and now it's becoming an analytics game. And so every institution in the world, all of your agencies have these big security control centers. We build all the analytics for many of you, and you're basically trying to find the bad guys that are injecting malware. Or if they're inside you, you're trying to find them as they move around. You're trying to find the footprints in the sand. That isn't going to work in an AI world. And it isn't going to work for the following reason. In an AI system, the way you corrupt it or make it do bad things is not to inject malware into it. Example, if you take an image recognition system trained on AI to recognize a stop sign, if you know enough about that training system, you can inject very small amounts of data into the training engines and get that system to learn and think it's seeing something else, such as a yield sign. Now, I don't need to tell you what that means for an autonomous car, but think about whether that was a medical device or a defense system or you name it. That is a big problem. So protecting the data and protecting the learning engines in these AI systems is where all the action is. Forget the malware. Focus on the data and protecting the data and your training engines in this AI world. So please, over the next day today, keep this security in mind. And people who understand this will be okay. People who don't understand this are going to have one god-awful time in the AI world. Secondly, we need to be conscious of bias. This paper was recently published by some colleagues up at MIT, which said that, hey, some of these systems now will recognize people of different color or gender more precisely than others. Now, why is that? Everyone sort of was surprised. I wasn't surprised, because basically these AI computing systems, I always say they're as dumb as this chair until you give it data to learn. We're very much like humans. What we know and how we react to things and our biases are the results of our experiences and the data we've received throughout our life. Same is true of these machines. So if you train it with the wrong data, if your data you put in has a bias, that machine will learn that bias. Keep that in mind. There are ways to deal with this. There are things you can put in the system to prevent those biases from showing through, but we need to be very conscious that these systems will not always be independent. They will pick up biases that we either feed into it or they see in the data. So again, we need to be careful how we use them. We also need to be very transparent in how we're using them because of this exact problem. So we in IBM have put together 3 principles as a result of everything we've learned about this. And I would encourage everyone to think about these, and if you're comfortable, adopt these. Number 1 is we have to be transparent. And we have said and we have pledged that we, in all of our products and services, if we use AI or machine learning any place in our products, we will tell you. We won't hide it as some black box in the back. And we will also tell you who trained it and what it's doing. So if you're a patient and you're looking at that screen, or a doctor with that cancer diagnosis treatment recommendation, we will tell you. We trained it with this data, with this doctor at Memorial Sloan Kettering, this, and this. We won't just say the machine knows the answer. That's a very dangerous place to be. And we will always go for the best training possible. Secondly, we fundamentally believe that the data and the insights these systems generate belong to the person who generated the data, owns the data, and did the analysis. This is not something we believe should be free. We should not democratize the value of these decisions. Otherwise, the value in the system will disappear. So it's very important that we protect the intellectual property in this new AI world. It'll be more difficult, but incredibly important. And then lastly, we believe that nobody should give up the right to that ownership of that data without permission. And this is, I think, really important. We've seen some examples recently of where arguably that's been misused. But again, it's your data, it's your insights, you need to know what's being done with it, and people should not be taking it and using it for other purposes. Lastly, on workforce then, so this is a different world. This is a different world. And the result of this is there's a tremendous gap in the number of people that can really understand artificial intelligence, even in the domains, and use it. And there's a tremendous gap in this area of cybersecurity, not just in the old analytics world, but in the new world of AI and data. Millions of job opportunities are arising from these technologies. Just as with every new technology transition, some jobs will be impacted. The opportunity here is enormous. And I think it's incumbent upon us as corporations and us as government to step up and help bring everyone along. The last thing we want is a society where there's the haves and the have-nots in an AI cloud-based world. We need to bridge that gap and pull people through. And we have a number of education programs, a number of different ways we're doing that. Sam mentioned Call for Code, which is our way, obviously, of helping people with disasters and hazards and things. But fundamentally, we want people to get on board and just start playing with this technology and learn about it. You may not be a PhD creating the next big, deep neural network algorithm, but you sure can get a great job in an industry such as healthcare, leveraging these technologies and working, in a sense, punching above your weight by leveraging these AI systems. So great opportunity for jobs, and I think we need to now figure out how do we bridge that chasm. So I'll end then with what this conference is all about is government. Just as I think every industry is going to be transformed by these technologies, I think every agency, every job position you're in is going to be transformed. And by the way, you'll need to transform because the citizens are going to be demanding it, because all this smarts is going to be in all the applications they're using, and they're going to get used to these things now and demand it of our government services. whether you're in the health end of it or the defense end of it or anything in between, every single one of these capabilities in governments are going to be transformed. And I'll conclude by, if I can get this to move, I'll conclude by saying that for IBM, we're 107 years old, not as old as the US government, but we've been around for a while. And this is a partnership that we highly value and we take incredibly seriously. All the way back to the mechanical compute days when we built the capability to create the Social Security system, which was a bet your company for IBM, through the moonshot, Apollo moonshot, where all the pictures we have, we went in and we counted the NASA jackets versus the IBM jackets in the control center. And because it was so highly computerized, there were more IBM jackets than there were NASA jackets in that control room. But we were just extremely proud to be part of those kinds of missions. And then fast forward to today, we are building for places like the Department of Energy, the largest supercomputing artificial intelligence systems in the world. And they're being delivered literally today as we sit here. So we are extremely proud of this partnership from the past, and we look forward to a tremendous future together. And I will say to all of you and with Sam that IBM is yours. Take advantage of us. We want to be your partners, and we will be here with you for the long haul. So thank you very much for the opportunity, and I hope this was a little bit of thought-provoking discussion to set up the day. Thank you very much. And now, Francis Rose, I'll bring back up for the next discussion. Francis, thank you.